And we're back. We just got through creating our tier 0 and tier 1 gateways. We built the tier 1 gateway in the lab. Now we're going to talk about static routing and dynamic routing. And we're going to talk about what makes these things different. And we're going to talk about how to configure these things, both static and dynamic routing, on a tier 0 gateway. Now, we've got static routing and dynamic routing, like we have said, well, 3 times already? And the difference here is simply that static routing is me actively programming a router, right? Me telling the router where it's going to find the different prefixes, where it needs to forward this prefix or that prefix or what have you. Where dynamic routing is simply running a program on the router itself to talk to other routers so that we can automate that process ultimately. So dynamic routing is just a matter of configuring another program on the router. Now, we can route using static routes, like we said. We can route dynamically using BGP. This is likely going to be the routing protocol that you use that gives us dynamic routing externally to the physical network. It gives us internal BGP. Oftentimes that's used inside of NSX, peering your service routers together so that we have some path resiliency. Or we could use OSPF. OSPF is a different routing protocol and is certainly very functional. It does exactly what we need it to do. But today it's a little bit less common with our NSX deployments. We can provide OSPF neighbor relationships using either point-to-point or broadcast networks, depending on what your configuration may be. Remember, we're going to tie together with your existing configuration. We're not looking here with NSX to overtake your core routing configurations. We want to work with your core routing configurations. So we can configure more or less however you might need to configure. Now, configuring static routes, let's start there. When we go in to edit our tier 0 gateway, we can, under the routing header, expand that out and create our static routes. Now, right below that, we can also set up a bidirectional forwarding detection, or BFD peer, to probe against, to make sure that that route, that next hop maybe, is still available, right? We want to configure both of these things so that we've got our routes and we've got somebody upstream that is communicating back and forth to let us know whether it's actually alive. Now, when we go into configure a static route, we need to define the network. So actually, before we define the network, we need to give the route a name, because this is just another object in NSX, just like we have seen over and over and over again. So we'll need to give that object a name and define the network, the prefix that we're trying to get to. And then we can go and set one or more next hops. So I can build these different next hops. I can define the routes through which those next hops are going to run, where we're going to forward those packets, and then we're going to save or add the configuration, then save the next hop, or the route object rather. And once that's done, we've got our static routes. It is that simple. Now, when we look at dynamic routing, there's a little bit more to it. Dynamic routing, whether we're looking at BGP or OSPF, these are separate configuration headers in our tier 0 gateway. So these are not under the routing header. There's a BGP header that we can look at to configure BGP, and there's a toggle to enable or disable BGP. We can define our local autonomous system number, in other words, the local numeric identifier for our gateway. We can choose our graceful restart settings. We can choose our inter-SR BGP configuration, whether that's on or off. So do we want the service routers peering with each other for resiliency? Do we want to enable equal cost multipathing? And then finally, we can set our BGP neighbors. When we set a BGP neighbor, we need to define the IP address of that neighbor. Who do we need to talk to establish that relationship? What is the autonomous system number of that neighbor? Do we want to allow autonomous system in, which is a kind of a multi-site configuration, generally speaking? And then finally, what is the source IP address for our requests to this neighbor? This will be the IP address of one of your uplink interfaces. Now, under the timers and password header that we see here, we can look at and set BGP timers. We can set BGP passwords, things like that. These things will be configured. Like I said a couple of minutes ago, we're going to configure these to work with your existing infrastructure, not redefine your existing infrastructure. Now, once we have our neighbors set, once the neighbor relationships are set, we can validate that they're working by looking at the state, right? The state should be success. That tells us, just like all the other state columns in the UI, it tells us that the BGP neighbor has been programmed into the data plane, so it's successfully programmed. And there's a little information icon, right? The little eye with the circle around it that we can click on right here. And that gives us essentially a get BGP neighbors output, right? If you're familiar with working with BGP on a traditional router, you can usually run a command like get BGP neighbors or show BGP neighbors or something like that to get information about your different neighbors. Well, this information button gives us that, except it gives it in a graphical format where we can look at the neighbor. We can see how many times we've exchanged prefixes, how many prefixes, and so on and so forth. This just helps us validate that we are successfully communicating with that BGP peer. In the context of BGP and the context of dynamic routing in general, we want to find ways to minimize the amount of data being transferred back and forth. We want to do that to save bandwidth. We want to minimize the size of the routing tables and so on. In BGP, we do that with a feature called route aggregation. In route aggregation, what we're going to do is we're going to specify maybe a larger prefix, and any prefixes that fit within that larger subnet will be advertised not individually, but simply through that aggregate prefix. Here we've got a case where we're setting up an aggregate prefix of 150.0.0.0/8, and we've got a couple of prefixes that will fit in that, right, that are covered by that larger prefix. So in this example, instead of advertising the two separate router prefixes, the 150.0 and the 150.128 prefixes, we're simply advertising the larger 150/8 prefix. Now, if we're looking at two routes, maybe the aggregation is not particularly valuable. But if you extrapolate this and expand this out to scale, where maybe I'm collecting tens or more prefixes in that aggregate, well, we start to see some benefits here. So to configure route aggregation, we have a route aggregation option in the BGP settings in the Tier 0 gateway, and I can simply set my aggregation where I can add individual aggregate prefixes as is necessary for my infrastructure. Now, OSPF, right? And before we dive too far into OSPF, let's think about this. I'm going to run probably one routing protocol, which means I'm going to run either OSPF or BGP. So if I'm going to run OSPF, then we probably want to go in and disable the BGP process, and then under the OSPF header, enable the OSPF process. And here we're going to, once we've enabled, configure our graceful restart configuration, whether we want to allow equal cost multipathing, and then we can go in and configure how we're going to build our neighbors. And we do that by first setting an area definition, right? So we need to create, or not create, but define the OSPF area in which we want to participate. And that's what we're doing here when we're setting our area definition. This is going to be either a normal area or an NSSA, or not so stubby area. And we'll have some kind of authentication to go with that, whether it's a pre-shared key or an MD5 sum. But we'll have some kind of authentication. We'll go ahead and save this. Once we save this, then we can go in the OSPF configuration and set our OSPF interfaces. So OSPF is not taking a precise neighbor configuration. We're saying, hey, this interface needs to belong in this OSPF area. And by doing that, OSPF is going to go and find all of the possible neighbors attached to that interface, attached to that network. OSPF typically works as a broadcast mechanism, but with our interfaces, this is where we're going to set whether we're looking at a broadcast or a point-to-point network. We said earlier that we support both. This is where we configure it. So we associate uplink interfaces with OSPF areas, and OSPF will automatically go out and discover all of the possible neighbors. Now, we can validate neighbor state. There's a view neighbors option in the OSPF configuration header on the Tier 0 gateway, and that's going to show us a list of all of the routers with which we have made a relationship. It'll show us our current timers, our hello and our dead timers to see when we last talked to the neighbor, when we're going to time that neighbor out if we don't get another hello or a response from a hello. We want to see the state of the neighbor. Now, the state here is not the realization state of a thing, right? The state here is the state of the neighbor, the OSPF state. What we want to see here is a full neighbor relationship. That's going to tell us that we have established our neighbor relationship and we are sending LSAs or link state advertisements back and forth so that we are sharing that information for the different routes. Now, just like BGP, we want to minimize the number of prefixes shared back and forth. In OSPF, we worry about the number of LSAs or link state advertisements that we're sharing back and forth, and we're going to help minimize that by setting up route summarization. Route summarization here is functionally like the route aggregation we talked about a minute ago, where if we have multiple prefixes that can fit within this summarized prefix that we configure, then we'll only advertise the one summarized prefix, right? And we can configure that here in route summarization. And just like the route aggregation in BGP, we add our summary prefixes and whether or not we want to advertise them right now and save that configuration. We can minimize the size of our routing tables. So, configuring dynamic routing is pretty simple, mechanically speaking. Designing a routing domain, that's a whole different game. We're not worried about that here. We're simply worried about how can you configure OSPF and BGP to work with your existing routing domain. So we've got a couple of labs where we're going to practice that. This first lab, lab number 8, is going to create a Tier 0 gateway and configure OSPF. So we're going to build a gateway. We are going to configure some uplinks. We're going to configure an OSPF area, attach the uplink to that area, and see our routes, make sure everything works, right? We're going to ultimately attach a Tier 1 gateway. We'll look at the network topology. We'll make sure everything functions. We'll do some pings back and forth in and out of NSX. When we're done with lab 8, we'll go ahead and move on to lab number 9, where we're going to kind of do the same thing. We're going to build another Tier 0 gateway with its own uplinks, but instead of using OSPF, we're going to configure that using BGP. And we're going to do the same kinds of things. We'll attach our Tier 1 gateway to the BGP Tier 0, and we'll do some validation to make sure our routing peers are working and that we can move traffic in and out of NSX. So go ahead and jump in to these two labs, right? Labs 8 and 9. And then in a little bit, when you're done with that, we'll come back here and go ahead and wrap up this particular section. See you guys in a few minutes. All right. So there we saw it. It wasn't all that difficult. It was really straightforward to set up. Once we talked through it, and then we kind of guided you through in the lab. It's pretty easy. You can take that back to your infrastructure and work with your BGP or OSPF engineers to integrate your NSX infrastructure into your core network. So what did we talk about? Well, we talked about everything we just did in the lab, right? We talked about static routing and tier 0 gateways. We talked about BGP. We talked about OSPF. And that's kind of it. If you come back, we've got more cool routing stuff that we have to talk about yet. So we're not done with this series. Come back. We'll see you soon.